So 2.9, the square root. Okay, this time I'm not going to put parentheses. Are you happy? 20.1. I have to have parentheses. So 40.19 inches, according to the model. Okay. Now in part B, oh, it also says the actual median height for boys at 48 is 40.8. Actual is 40.8 inches. And we're asked now, how well does the model describe the actual height? Do you consider that the model is good for 48 months? This is the correct height, and we get this. I would say myself that this is perfect. Now, if it comes to something that may kill somebody, it's a huge error. But this is just an idea about the median height of boys at 48, and I think the model is very good. That's my opinion. Of course, it's my phone. I'm sorry. I'm not going to look for it. Sorry about that. Okay, part C. Use the model to find the average rate of change in inches per month between
What was B?
birth and, I'm sorry?
What was part B?
I'm just reading it.
Oh, you said C. Well, that's B. You put A. But that way.
Oh, no, that was A. Sorry. Part B is coming up. Oh, no, part A, I'm sorry. Part A, you're right, this is B. Part A was describing, I already did. It has a stretch of 2.9. Let's write it. So stretch, vertical stretch of 2.9 and vertical shift of 20.1 up. Okay, so this is C, indeed. Between 0 and 10. So between 0 months and 10 months, they want us to determine the average rate of change of the median height. How do I determine the average rate of change between 0 and 10? Can anyone dictate?
Y minus
F of y2, f of x2. Let's write it first. So see it like this if you want. That's perfect. But basically for the average rate of change is f of x2 minus f of x1. This is giving the, this is x2 and this is x1, over x2 minus x1. So x2 minus x1 is easy. That's 10 minus 0. In the function, I have to plug in 10 and I have to plug in 0. So let's go back to the graphing calculator, and this time, let's just plug it in y equals 2.9, the square root of x plus 20.1. And then we go to second and table. I have to change because they always goes to the default. All right. So go to second and table, and you plug in 0, and we plug in 10, and we can also plug in 48 as we did a minute ago, but we don't need that anymore. So we get, let's see, we get 29.271 minus 20.1. So the numerator is, I think it's 9.171 divided by 10, which is 0.92. Measurement unit, please. It's a rate of change. It has to have 2 measurement units. One measurement unit coming from the measurement unit of the numerator over the measurement unit of the denominator. What is the numerator measured in? Good. What is the denominator measured in? So it appears that between 0 months and 10 months, boys, their height increases at a rate of roughly 1 inch per month, roughly. So it appears that between 0 and 10 months old, their height, the median height, their height, boys' height increases by, on average, roughly by 1 inch per month. Okay, part D now. They're asking us to do the same thing between 50 and 60. So 50 and 60 this time. I go back to my table. I plug in 50. And I plug in 60. Then I copy the numbers. So the average for 50 comma 60 is 42.563 minus 40.606. Still leave 60 minus 50. Same thing, exactly what we wrote, just a different, yes?
I know you did the chart thing, but like what are you multiplying or adding or whatever you plug in 50, what two numbers is it calculating to give this number?
Say it again.
Like,
This is in y equals. We have the function put in.
okay.
So when I go to a second and table,
Okay, but like you're redoing that whole formula.
that's the only thing I have.
For
So
next year.
it's a very good question. So this is the x I put in, and this is the only function I have in the graphing calculator. It's called y1. Very good question. I should have said that. My apologies. So that's what I have. I only have y1. Now if I had y2, y3, then I would get more columns filled up. But I only have this function plugged in. You don't have to use a table, but then it will be much longer for you to type it up. So you can do this, like we did here, but then you will have to do it 4 times. Instead of having the function plugged in and you just plug in quickly in the function. So it's up to you. Any option is fine. Okay, so the denominator is 10. And what we have in the numerator, is it 9, right? And 1. Yes, 1.9 approximately. So this happens to be 0.19. Measurement unit. It's the same thing, it's just different months. So inches per month, correct? Good. So what do we notice here? That between the age of 0 and 10, they grow faster or slower than between 50 and 60. Much faster. Almost 5 times faster. Because this is 0.2 and this is almost 1. So if you multiply this by 5, you will roughly get that. So it's much faster between 0, which makes sense, right? And we see that in the graph. See how fast this is going? And then between 50 and 60, much slower. So the slope here between 0 and 10 is this. Between the points with 0 and 10 is this. But look at the slope of the line between 50 and 60 versus this one. Much faster versus this one. Good. Any questions? We have, I know, 5 minutes left. I just want to present the last one. Any questions? So from the list of transformations, we looked at the horizontal, the vertical one. All these are pretty common sense, I would say. This one, the horizontal one, not really. So it's not going to be what you expect. But I'm going to try and make it very easy. So let's look at the following example. I want f of twice x. And I'm telling you this time, I'm going to call this a different, I'm going to call it g, not to be confused with Well, actually, I do need f. Sorry. I do need f. So I'm going to delete that. So f of x is x cubed. Can you please tell me, if I ask you to evaluate this function at twice x, what will you write? How will you determine that?
2x minus 6.
Very good. To the third power. Awesome. Great job. I'm erasing this so it doesn't confuse anyone when they print out. Okay. So indeed, as we know, some of you did have some difficulties with evaluating functions. So please be careful. Okay, so then can anyone simplify this without parentheses for us? We know how to take a product to the third power. I know we know that. I don't have any doubt. How much is 2 to the third? X to the... I cannot pick and choose. I have to cube everything. I have to cube 2 and I have to cube x. Good. Very good. So forget about the intermediate step. And I'm going to ask you, what did I change now? Did I change x or did I change y? Right. I multiplied x by 2, correct? Okay. Now forget about that for a moment, please. And tell me how to graph this. This is x cubed. And how do I graph 8x cubed?
Of 8.
Vertical stretching by a factor of 8, correct? So remember, we had x squared. I know you've seen this the first time. It needs time. So I have x squared. And then when we graphed 2x squared, we did this. Agreed? And now I have x cubed. I want 8x cubed. What do I do again? Do I do this, vertical shrinking, or I multiply by 8 and I do vertical stretching? Okay, so keep that in mind. What did we do initially? We multiplied x by 2. So you would expect that the graph would expand, right? And multiply x by 2. Instead, look what happens. So it's a horizontal shrinking by a factor of 1/2. I know you wouldn't expect that, but that's what happens. So when we change x into twice x, this is a horizontal shrinking. Meaning, if this is x cubed, f of twice x will not do this, as you would expect, because you expect to expand x. No, you will do this. So this is f of twice x. This is f of x, and this is 8x cubed.
So is that the same as vertical stretching?
Exactly. Yes, it is.